All right, maybe we should get started. This probably is a little bit loud. Okay. So I'm Alex Wendt. This is a conference on, or workshop on quantum theory in the international. I'm a professor in political science, and also I have a half-time appointment over here at the Mershon Center. And everybody calls me Alex, so that's what you guys should all call me. I wanted to also call attention to Stephen. Where is Stephen? He just stepped out, I think. Stephen is kind of our sort of concierge and host, in a sense. So any questions you have about anything pertaining to the logistics or anything else about the conference, talk to Stephen. Or me if you have to. So, but where is Stephen? He'll come in a second and we'll introduce him then. So, I should also call attention to the fact that this whole workshop was made possible by the Mershon Center. Every year now we do one big event like this, and one of the members of the Mershon faculty is chosen to kind of organize the event. So this year it was my turn, and even after my colleagues saw what this was going to be about, they went ahead and said it was okay. So that's a good sign. But they are the ones who are the real hosts in a sense, and I'm just kind of the front man. Just logistically, restrooms are on the first floor over there in the corner. There's several there, so there shouldn't be any problem there. And so I guess what I wanted to do in my remarks up front is just two things: some organizational comments, and then a few intellectual comments as well of my own. I want to talk less than 30 minutes, and so we can turn it over to our other two speakers, which we have before a break, and I'll introduce them at the end. So, okay, so I guess I wanted to begin by just noting that this is probably, I mean, people that are officially part of the program for this workshop, and I hope I can say this affectionately and not abusively, this is probably the motliest crew of people I have ever been part of a scholarly conference with. And the reason is that there are, I counted 7 disciplines among the people in the group, 11 countries, and also the age distribution. We've got 3 undergraduates, and then there are people like me and Peter and James at the other end of the spectrum, we'll just say. So, so it's really an incredibly diverse group of people in every possible sense. And the other thing is that of the outside, there are 21 people who came in from outside, and then 6 who are internal, who are officially part of the program. Of the 21 outsiders, 2/3 of them I've never met. So it's a wing and a prayer here, and I don't know what we're getting. Okay, so who knows how this is going to go. But it should be fun. That's my hope anyway. So, okay. And let's see. Yeah, I think the thing that attracts me to this whole workshop in particular, I think it's the first time that, at least I've ever seen, a critical mass of people who are interested in quantum theory and social science come together. And so in that sense, it should be a very wide open and completely unique experience, at least for me. So today is the plan for the 2 days is that today is kind of the technical day. After some opening stage setting remarks by James and Peter and I, we're going to turn to a tutorial, in effect, by Michael Schnabel. Where is Michael? He's right there. Okay. And he's going to just spend an hour and a half teaching us about quantum theory. I think without the math, right? Mostly. Okay. So we'll see. And then after that, we'll have some more technical papers and stuff. And then tomorrow, all the papers are more about, they're more qualitative, and they're more about IR. And for those of you among the unwashed, not in political science, IR stands for International Relations, and you're going to be hearing that phrase all the time. So that's our nominal substantive area here, but really this is a workshop on social science in general, okay? But we'll be talking about IR in particular most of the time. And then at the end of the conference, after the end of the last sessions tomorrow, Steve Fuller is going to comment on the whole thing. He's a very prominent sociologist and philosopher of science, and I thought he would be able to give us a very interesting external perspective on the whole proceedings. Dinner tonight will be just more logistics. Dinner tonight will be Indian, very casual. It's kind of a hole-in-the-wall place, but I've been going there for years. Fantastic Indian food. Hopefully it'll suit all you guys. Tomorrow we have a nice fancy dinner. It's more of an American steak, potatoes, all that kind of stuff. But we'll worry about the logistics on that at the end today. And then in terms of parliamentary procedure, there are a lot of papers that people are presenting, or some are just memos. They're not all papers. And of course, many of them are just coming in now. So my assumption is that hardly anybody has read anything. Okay, and that's just as it is. And that's fine, in part because this conference is not really about the papers. It's really about the networking aspect and kind of building a community of people. But there will be papers, and so I'm giving everybody 30 minutes tops, and I'm going to try to police that as hard as I can. And so I would encourage all the speakers to, talk for 15 and then do Q&A for 15. So we at least have some back and forth. And what I'll do is I'll keep, in terms of the questions, I think what I'm going to try to do is keep a list, and I'll just sit here, and then if you want to get on, if you want to speak, if you want to ask a question or whatever, just get my attention somehow. I'll put you on the list. If you have a question that immediately follows up on somebody else's question or an answer that the speaker is giving, you can have a two-fingered intervention where you can kind of intervene, overrule me in a sense, or get me to see that it's a two-finger. In any event, that's kind of the usual rule of thumb in a political science workshop, so two-fingered interventions. There are also two changes, last-minute changes to the program. Karen Firka, who is supposed to be joining us from St. Andrews in Scotland, forgot her passport once she got to the airport, her British passport. So she could have left Britain, but she could not have gotten back in, apparently. So she had to decline. She was very disappointed. And actually, her paper is the only paper among the entire set that really addresses ethical issues in a direct way. And she's very eager to get any comments that anybody has time to give her, because it's something that she wrote specifically for the workshop and is not sure where else she could present it. So, and the ethical dimension is something that I think does come up in natural ways, as we'll see. So if you have any comments for her, I'm sure she'd be delighted to get them. So we had to drop her, but we added Catherine Schaffer. Is it Schaffer? Schaefer? Schaefer, okay. Who's a physicist, actually, and she'll be talking this afternoon. So we actually have several physicists who are going to be educating us in different ways. And so Catherine has kindly agreed to step in. So, and the title of her talk is actually Translating Quantum Physics, a Tentative Taxonomy. And so I think it's actually going to be a very useful stage-setting exercise as well. The final academic, non-intellectual thing I wanted to mention up front is in terms of, usually at a workshop like this, you talk about what the product is going to be at the end, the deliverables and so on. Usually in these kinds of settings, you would aim for a special issue of a journal or maybe an edited volume. Either of those would be the first of its kind in IR, if it's about quantum. But I'm not sure that that's the best way to go with this particular set of papers or workshop. It seems to me that it might, given the diversity of the workshop, it might actually make more sense for everybody to just take their own paper and go seed their own area of the field and kind of spread the word rather than concentrating everything into a single edited volume about IR. Okay, so we can talk about that over the course of the workshop. But I'll be very interested to get everybody's views on what to do at the end. But that's my kind of initial intuition, is that it's better to spread the wealth around rather than trying to concentrate it. Okay. But having said that, Mark Salter, who I think is not yet here, but there are a number of people who are still en route, actually. So Mark Salter is the editor of Security Dialogue, which is one of the premier European security journals in IR. And he was already planning to do an entire special issue on quantum and IR very, very soon. And so he will be looking for some papers from this set or this group to add to his other papers that he already has in the box for his special issues. So there will be some kind of product coming out of this, even if it's not a Mershon product in particular. But I guess in a way this doesn't bother me if there's no actual product, because for me this whole thing is totally exploratory and playful. I want to set a playful tone here. This is all wide open ideas. I have no idea what you guys are going to say. And there's a networking dimension here too. I mean, in a sense, what I've done is this is really the island of lost souls, basically. It's a bunch of people from all over the world, really, with this really weird interest that somehow I got connected up with, and now we're here. So it's really about getting to know each other and just talking and having a good time. So we don't have to be too rigorous in this kind of a setting. Okay, let me say a few words then on the more intellectual side, since I'm doing well on time, so that's good. The book that I wrote, here we are, is, I want to say just a few words about it, and then I want to specifically talk about 4 issues that I see emerging from either the book or conversations I've had with other people since the book, and that might be part of our agenda for today. So the book is very speculative. It makes many controversial arguments. I should emphasize it's only one way that you might get into the idea of a quantum social science. So even if you reject the main argument, and many people do, there are other ways to motivate the work in this area. So you don't actually have to buy into a whole lot of the book itself. But the main argument of the book, just briefly, is that human beings, and for that matter all organisms, I claim really are macroscopic quantum mechanical systems. Walking wave functions is my kind of bumper sticker version. This is controversial because it has long been assumed that interesting quantum effects are present only at the subatomic level. Okay, and at the macroscopic level of human beings, classical physics rules, classical mechanics dominates, not quantum. And actually David Waldner's paper, and he's not yet here either, but he's presenting a nice paper that was published last summer, actually, where he lays out the standard orthodox view very, very eloquently. So you'll get that perspective in full tomorrow afternoon. And actually, if you think about it, if you think about the training that social scientists get methodologically and statistics and everything, all the training we get is classical probability theory, classical statistics, classical logic, classical game theory. It's all classical. None of their quantum counterparts are ever raised in methods training, for example, among social scientists. So it's clearly a classical sort of subtext to social science as a whole, I would argue anyway. And my claim in the book is that this basic assumption about social life, that it's classical, is a mistake, and that correcting this error and refounding social science on a quantum basis would solve a lot of long-standing problems in all of our fields. And I'm not going to go over those in particular, but I do want to say just a couple things. First of all, and I guess these are two kinds of arguments for the argument I'm making in the book. Okay, one is growing empirical evidence that's coming out of quantum decision theory and quantum cognition literature, where they're basically using the quantum formalism to predict behavior much better than the standard rational choice model ever was, which was a classical model. And so that's, I think, extremely important research, and I think it's the best evidence of all for taking some kind of quantum perspective on social life. And then on top of that behavioral evidence, there's a second contribution, I think, here of this larger quantum story, which is the possibility of explaining consciousness, which was what got me into the book in the first place. I was interested in the mind-body problem. I was not interested in quantum decision theory because it didn't even exist when I started the book. But consciousness to me is a fundamental problem of social science. It has been utterly impervious to a classical mechanical interpretation or explanation as far as I can tell. And I can see very clearly how a quantum argument might be used to make sense of consciousness, and that's what I try to do in a good portion of the book. Okay. So my key claim, and this is something many of you guys may disagree with or something we can talk about at various points, is that human beings don't just mimic quantum behavior. We're not quantum-like, is the phrase that some people are using, but we are actually quantum beings. And so in that sense, a quantum social science is not like an optional metaphor that we can pick up or drop as you will, because if people really are quantum beings, then we must have a quantum social science for their proper understanding of their behavior. Otherwise, we're just going to screw it all up, if we really are quantum beings. So in that sense, I think the claim of whether we really are or not actually makes a big difference. All right, so in the book, I play out this ontology for a lot of different issues. I'm not going to go through that. What I want to do is briefly wrap up by just raising 4 issues that I think, at least for me, are things that I'm hoping to get some insight from you guys on. So the first, and actually this I think relates directly actually to Catherine's paper this afternoon, is an issue of translation, which is how to bring the apparatus of quantum theory to bear, which was designed for physics, after all, how to bring that apparatus to bear on issues of social science. Okay. And there are different kind of levels of abstraction there that one might think about. There's an empirical question of how do you actually use the formalism to talk about experiments or talk about data and so on at a very kind of concrete, very empirical level. Secondly, more abstractly, there's the level of kind of conceptualization and theorization. It seems to me a quantum framework would lead people to think very differently about a lot of different concepts, a lot of our theoretical claims. So basically it's theorizing. It's kind of the second level, I think, where there's going to be translation issues. And then finally there's the issue of epistemology, okay, which is what are the implications of this framework for thinking about consciousness and subjectivity, and how do we bring subjectivity into social science, which has been my agenda for some time now. Okay. So there are various how questions to use this formalism, or even whether to use the formalism at all, in social science at different levels. Okay, so that's one. Second of the four that I wanted to point to is a question of value added. Okay, and this is not so much how to translate, but why translate. Okay, after all, social scientists have been doing their business for over a century perfectly well without quantum theory. So what do we need quantum theory for? To tell us what we already know. And I view this as a very serious challenge. And in a way, the one way to think about it is social scientists, or any scientists, well, social scientists face a choice between starting with kind of folk psychology, which is what most of us do. We all use rational choice as a kind of folk psychology, which is phenomenological. It assumes that people have minds, and their minds behave in certain ways, and so it starts with the mind. That's kind of the standard approach in social science. Whereas physicists, of course, are talking about physics. They're talking about a physicalist, physical world in which mind doesn't even appear. Okay, so the issue of why translate is why should we, if we already have a good folk psychological discourse to talk about social life, and we do, what do we need to bring in this very alien, why should we bring in this very alien physical discourse on top of it, okay, or in addition, okay? And part of the answer, in my view, is that we don't have any choice, okay, because any folk psychological story you tell has got to have a physical basis, and in my view, that's going to be a quantum basis, okay? But one complication here on this value added and why do this translation, one big complication is that my claim anyway in the book is that everything in our mind is quantum mechanical. And if that's true, then the folk psychology that social scientists are using to talk about social life is also quantum mechanical already, okay? And so then why do we need to sort of make that explicit? What's the point of adding the physical dimension if we already are doing, in a sense, implicitly at least, some kind of quantum social science? On the other hand, when we teach social science to our graduate students and undergraduates, we teach them classical thinking, all right? And that's the problem, is that it's what we're teaching our people now is a mess. It's a melange of both quantum and classical thinking that hasn't been separated and sorted out. And so, and I think one effect of this, of teaching, well, actually I'm going to raise this issue in a minute. I'll defer this one in a minute, okay? Okay, so there is an issue of value added. And I think that issue is actually particularly challenging for anybody who's not a positivist, who's more on the interpretive side of social science, because they're already talking about subjectivity, meaning, consciousness, norms, all the stuff that a quantum perspective might speak to. But they're already doing it, and they've got good language to use already. So why bring in quantum? So I think in a way my toughest audience are my natural allies in a way, but they're also I think likely to be skeptical, or at least some of them. I've had very different reactions to the book from that community. Okay. Third of the four, now I'll be almost done here, is the issue of realism, which I alluded to above, namely, are human beings and their behavior really quantum or just quantum-like? Or are we just talking here about a metaphor, which would be even a looser way of talking? Okay. The non-realist views are much easier to defend, and if you don't need to defend a realist view, there's every reason not to. And actually, physicists themselves rarely talk about what's really going on. They just, what is the phrase? Shut up and calculate. They teach students to do that, right? So they teach students not to think about the underlying ontology. And I think that's sort of a non-realist approach to doing the physics. And so those are easier to defend, and it's hard to publish this work as it is, so why add really controversial claims about, metaphysics on top of what is already a difficult argument? And so I get that. On the other hand, though, if we assume that we're only talking about a metaphor, or that our behavior is quantum-like, but not really quantum, then the implicit assumption there, I think, that's being made is that social life is really classical. Right? If you say it's just a metaphor over here, then what you're really saying is over here it's really classical. And I would say, A, there's zero evidence at all that human beings are classical machines, and so I would invite debate about that. And there's also the question, if you think human beings are really classical, and if the evidence for quantum-like behavior grows, which it seems to be growing rapidly, there's going to be a change in the burden of proof here. The burden of proof right now is on the quantum people to say that this framework is any use at all. Okay? But if the evidence continues to mount, that we engage in a lot of quantum-like behavior, then it seems to me the burden of proof shifts to the orthodoxy, and they need to explain why is it that supposedly classical machines like human beings engage in all this quantum behavior. That was never expected when people invented rational choice theory. People expected people to behave rationally, right? But that's not what we do. We behave quantumly. So I would like to hear from the orthodoxy eventually how they explain that if they're going to say that this approach is wrong. Okay. And then finally, the last point I want to make is about pedagogy, which is that if the realist claim is true and human beings really are quantum beings, then I think that raises what you could almost call it a civilizational question, which is that basically what this implies is that for 3 centuries now we have been teaching our children through rational choice theory, statistics, probability, we've been teaching our kids from kindergarten on up to think of themselves in classical terms, I think at least implicitly. And if we're doing that, and if in fact we're not classical beings, then that would be, I think that's a type 1 error, where you reject a true theory as false. Is that a type 1 error? Somebody's got to know what a type 1 error is here. All right, I think it's a type 1 error. I'm not sure, it might be a type 2, but okay. The point is, if you reject a true theory if you reject a true theory as false, you're making a terrible, terrible mistake. And it's a political mistake, okay? Because the political mistake here is if we teach ourselves that we're only classical beings, then we're basically teaching ourselves to restrict ourselves, our behavior and our thinking, to the classical worldview, which of course is a dead worldview. Classical physics was designed to model dead phenomena, not living phenomena, right? And so if we see ourselves in this much more restricted, dead way, as if we were dead, okay, it's hard to have much politics if you're dead, okay? It's hard to change anything if you're dead, right? So I view this, if we are actually in our pedagogical systems training classical thinkers from the ground up, we are limiting human potential both at the individual level, where I think this is a recipe for neurosis. I mean, if people are crazy or neurotic, maybe it's because they're too classical. And it also limits our potential at the collective level, because it's harder to imagine solutions to collective action problems and all the other things that the rational choice theorists tell us can't be solved if you're thinking classically. So being able to think quantumly, I think, would have a dramatic effect potentially on human potentiality at the both individual and the collective level. So I think everything is at stake here, actually. This is not just an academic conference about abstract questions of epistemology and ontology. I think it's a worldview that's at stake. I personally view quantum social science as an insurgency, and it's going to take decades to realize and sort of win the war, so to speak. But I would say it's just a matter of time. So, okay. I want to turn the floor over. Is there anybody want to follow up? I got a couple minutes because I did well. Anybody want to follow up with anything in particular now, or should we just? Okay, all right. We'll leave it at that for the time being. All right. So I'm not quite sure how to introduce the next 2 speakers. I know James Derian here on the end, and then Peter Katzenstein down here in the corner. I've known James and Peter for a long time, over 20 years. They're both very prominent IR scholars. James has been doing quantum stuff on his own, totally independent of me, for a number of years, and has a really cool, as you'll see in his presentation, just a very interdisciplinary multimedia kind of approach that's building communities and making linkages to all kinds of interesting things. And so James will give you an overview of his stuff to kind of help you see the range of potential connections one can make. And then Peter, and I guess I can say what I'll say about Peter now. Peter and I go back even longer than James and I do, and he's one of the most eminent scholars in the field. He's also widely reputed to be the best PhD advisor in political science. Peter, I'm not sure if you knew that, but that is your reputation. You did know that? Okay. And actually, Peter, the story about Peter, for me personally, is that my earlier work in the early 90s was kind of on social construction and IR, and it was a boutique kind of thing. There weren't a lot of people doing this. It was kind of weird. People weren't sure what to make of it and so on. And then Peter read my stuff and kind of got on board, and then organized this very prominent edited volume, which got a lot of attention. And in a sense, what Peter did was, to use language that Steve Fuller has used, Peter redeemed my earlier work, basically, and made it viable. So I'm hoping he can pull off the same trick again now. Okay, so that's what his role is here, is to somehow redeem whatever I've created in this discussion. So, and I would also say that at my age, Peter is also one of the very few people who is old enough now to be my actual mentor. So he's one of, I'm delighted that he was able to come. So I'm going to leave it at that and turn it over to James, and then we'll go to Peter, and then we'll take a break, and then we'll just see what happens. Okay, so.
We're all seeking redemption. First, some apologies. I got a dreaded head cold. I've been traveling nonstop for 3 weeks, so I'm hearing you and seeing you through a fog. I'm going to blame my cold medicine if my thinking's a little fuzzy. And rather than force you to listen to my Leonard Cohen voice for too long, I'm going to keep my remarks fairly short, try to frame some of our project, and then since I'm a documentary filmmaker as well, I'm going to show rather than tell and give you the highlight reel from our 4th annual Q Symposium, which we hold every year at the Q station, where they used to quarantine people coming in from ships into Sydney. Now we quarantine a motley group. And they spend 2 or 3 days here. Some of you have been there. Some of you have been there more than once. And it's a unique event, and we record everything, and we're turning it into a documentary film, because I believe, like Alex does, that this is not just an academic exercise. This is something very, very important, and it's as evangelical as I've ever gotten with anything, that it's important to get this out to as wide an audience as possible. An academic audience, to be sure, but that's why we use multimedia. So what I want to present today is something of a revisionist history of the past century, which I believe, like Alex, that quantum is really a civilizational issue. And I think that it's been a force field. It's been contained by classical disciplining. And I think it has the potential for something entirely new, a collective Weltgeist. But also we have to see the dark side of quantum. It's also a Weltanschauungskrieg. I'm using all this German for Peter's sake. It's a worldview for war as well. So this is something that we're grappling with, that every new technology, every new worldview, every new cosmology, is born out of war usually and seems to further war. So that's something that I'm very concerned about. Now let me give you the short version of how I see the last century, and it goes like this. It goes from the smallest to the largest magnitudes of energy, matter of information, the world as we know it, from geo then to astro to biopolitics. And it's really been about a transformation through a series of scientific discoveries that have challenged not only Newtonian physics of space and time and matter, but also many of the commonsensical philosophical assumptions that underlie much of what we know about reality itself. And I think it really does amount to a quantum revolution. It's rocking many of the philosophical as well as scientific verities of the 20th century, of the 21st century. And I think it's time to take a clear-eyed view at the dark as well as the light side of quantum and how it's going to impact peace and security. Now, like all genealogies, the question is, where do you start? You start at the end, but then where do you see the different turnings? Many people start with 1939 when John Wheeler and Niels Bohr wrote their famous article on nuclear fission, the possibility of nuclear fission not just being for peaceful purposes, and then this was then taken up by Leo Szilard and Albert Einstein, who then wrote a letter to Franklin Delano Roosevelt that led to Los Alamos, led to the dropping of 2 atomic bombs and a nuclear arms race. That's part of the quantum revolution. We have to recognize that. But I start further back. I start back in, I think we have to start at the turn of the century, when it was a pretty remarkable year, because the simultaneous discovery of quantum, these discrete, discontinuous packets of energy, by Max Planck, it's at the same time that Lord Kelvin said, there's nothing new to be discovered in physics. So we see this over and over again, these moments where declaration, there's nothing new, and then suddenly this great disruption. And this is true of 5 overlapping phases of quantum discoveries. So the first phase was cosmic. It was set in motion by Einstein, who built upon Planck's quantum discovery, produced his famous treatises on dilation, contraction, simultaneity of space-time, special theory of relativity in 1905, the general theory of relativity in 1916, space curving, time warping. Einstein became the first pop star physicist. But it's important to remember, Einstein probably would not have become that pop star if it hadn't been for Eddington having the means to measure his theory with the first solar eclipse. Without that measurement, there would have been another 20-odd years for the next, before Einstein's theory, I think, would have really taken hold. So science is really all about measurement. And I've said this to Alex several times, probably no one's going to truly believe Alex's theory until we measure those little nanotubes, microtubules. But I think that we have to see that the theories here precede, the measurements follow. And the thought experiments that we conduct here, I think, are very, very important. The second phase, I'm going to skip through these pretty quickly, but it's really the revolution that we all know about. Niels Bohr, Werner Heisenberg, Wolfgang Pauli, Louis de Broglie, Max Born, Paul Dirac, Erwin Schrödinger. This remarkable moment, one of the great internationalist collaborations of science of the 20s. The Solvay conferences, the speech that Bohr gives at Cuomo on complementarity. This is like something that I think we're trying to reclaim somewhat here, because really what happened, of course, we all know, is that great internationalist collaboration ended with the creation of the nuclear weapon, but the physicists stopped talking to each other. And when they did talk to each other, they didn't have much to say to each other. The famous encounter between Niels Bohr and Heisenberg in Copenhagen as the classic example of this, where we see the interwar descending into nationalism and physics for hire, physics for national security. And that's where I think we can learn from the interwar. I think we have to try to avoid another interwar when it comes to quantum technologies, because we are entering a new period. Many of the principles that we know of complementarity, uncertainty, entanglement, tunneling, teleportation, superposition, wave function, all the core concepts, elements of quantum mechanics emerged in this period, repudiated much of the Newtonian physics at the microcosmic level. But the third phase is one of quantum innovation and technology. From the wartime production of nuclear weapons to the post-war invention of lasers, transistors, microprocessors, computers, mobile phones, applications of quantum mechanics across the board disrupted the industrial age and ushered in what we now call the information age, and I think one day we'll be calling the quantum age. In this period, we have Richard Feynman's conceptualization of quantum computing in 1982, 1984, Peter Shor's formulation of quantum algorithms in 1994. This opened this radical development of being able to, for the first time, not simply conceptualize, but construct qubits. We're probably going to get into qubits later in quantum computing, but this is the radical idea of superposition entanglement, allowing incredible exponential increase in computation. Being able to make as many computations as there are atoms in the universe in hours instead of in hundreds of years that would happen with binary computations. So this new phase is something that very much interests us because it's happening at Sydney, and it's happening in many of the major superpowers, great powers, but also people are not paying attention to the fact it might be happening in places like Singapore and others. That's why I say we should treat the quantum revolution as a permanent revolution. It could be one in which stages are skipped. We might be overlooking the powers that don't have to go through the same stages of development as a permanent revolution, which has usually a political subsidiary. It does mean that whoever becomes the first quantum have in quantum communication, control, and computing and artificial intelligence is going to leapfrog in the great power game. This is something we're spending quite a bit of time on. So we're looking through Project Q, which is funded by the Carnegie Corporation, about this race for what's called quantum supremacy, which is kind of a overdrawn word for just simply saying that the quantum computer is going to be able to do something that classical computers cannot do, can do it better, faster, things like optimization, the traveling salesman issue, simulations, predictions for everything from like climate change, but also it'll inevitably be weaponized. We go around and we do interviews. We've been to Google Labs, we've been to Microsoft Q Station, we've been to NASA, we've gone to all the places where the labs now are, first time ever, moving from a 15-qubit computer to a 49, 52-qubit computer. And it's not going to be anything you can make in your garage. It requires intensive capital, the refrigeration, getting it down to as close to near zero, absolute zero as possible, shielding from electromagnetic interference. But every stage of technology, we see the increasing capacity for adaptation, and that's going to be a big factor. These computers are not being made by hippies in garages, but they are being made in places that we are not seeing or looking, and one of the places that we're going to in May is China, which is leading the way in quantum telecommunication, but also in quantum computing. So different than Alex, we're looking more sort of the technology, but like Alex, I do think there's a convergence going on. I think in the ontic, in the epistemic, in the technic, can I use that? In the technology, there is a convergence, and that's going to be truly revolutionary. It's going to change the way we think, it's going to change the way we do our everything from trading on stock markets, how we fight wars, all the fundamentals. And it's like artificial intelligence. It might not come as soon as some people are predicting, but it will come. Now, Alex, I have about 10 minutes left, or? Yeah. I just want to set this up, what I'm going to show you. I think there is going to be a revolution in quantum affairs. You've probably heard about a revolution in military affairs. There's already been slides leaked from the NSA showing that they're talking about a post-quantum encryption, because one of the things that quantum can do very, very well is, A, decrypt everything, because it's very good at prime factoring, which is the basis for much of the public encryption. But it also can create undecryptable, meaning totally unbreakable codes. And this is the one thing that's got the U.S. very concerned right now, because the Chinese have supremacy in this area. So what's the promise and what's the peril of the quantum revolution is what we're spending a lot of time looking at. And it calls for a watchfulness, and in Einstein's words, quick action. And these are the questions that we're grappling with, and I hope you're going to be able to provide some of the answers at this event for us, because we've not yet exhausted the possibilities. Who will benefit? Who will be harmed from quantum computing and communications? Will a new power and security gap open up between quantum haves and quantum have-nots? What are the risks and benefits of a quantum race? What would a quantum accident look like? How will quantum be weaponized? Can quantum technologies be managed, regulated, and governed for the public good? Could quantum produce sentient programs, spheral algorithms, and machinic forms of intelligence that supersede or even prove hostile to humans? Every place we go to that has a quantum program also has a quantum artificial intelligence program. So I think these questions call for new modes of thinking, not just to understand, but to anticipate and hopefully manage what's going to come next. It does require a multidisciplinary approach, particularly between the sciences and the humanities and the social sciences, but also getting dirty, working with governments, working with corporations, perhaps creating codes of ethics, new regulatory processes for a totally new technology. So to give you a sense of what this is the highlight reel that we put together for the 4th annual symposium. I apologize if some of you have seen it at the ISA. I don't see a mouse here. Stephen, if it's... I'll just let you, right here. I'll just let you bring it up. Can we put the lights down too before we shut? Maybe newer sound, yeah.
All set?
I think this kind of project is really useful because you're getting physicists together with people who are used to thinking about policy to try to say, here are the really important benefits that are coming with these quantum technologies.
This is a very different workshop for me. I've really enjoyed it. Most places I go, it's just technologists, very optimistic about everything that we do. They don't ask questions.
That it's really important to get scientists and social scientists together and conversing and talking. We both learn from each other. I think it's really good.
Start to conceptualize quantum as an opportunity instead of as a competition.
We are enjoined to debate this issue, particularly at Sydney, because it's leading the way. We should be having this debate, I think, before rather than after quantum goes online. It's because we've seen a legacy of policy lagging behind technological innovation.
Who wins and loses the quantum race, and also who gets to pick the winners and losers?
China or the US are two of the options that could win the quantum race.
What if one country attains supremacy of quantum communications before anybody else? Then that will certainly tempt more belligerent forces within those societies to be a little more adventurous. There may be a window where any asymmetry raises the likelihood of conflict.
If you want to change the world, we're going to need incredibly powerful machines built from qubits, fundamental building blocks of quantum computers that have, that are far more perfect and far more protected from their environments than anything we could see today.
I don't think questions about interpretation are just discussed by philosophers.
Taking models, theories that in some sense work within the natural science realm, like quantum mechanics, and trying to play around with it somewhat and seeing what kind of understanding of the social world we might get from it.
What intervention points stand to be most useful in terms of outcomes that we may desire versus outcomes that we fear?
Essentially redundancy of humanity as such, because we will have a complete victory of capitalism if this technology is allowed to happen. Because you can, we've seen this now, the machine learning is replacing cognitive tasks.
This is a technology, one that will transform warfare, and transform warfare in terrible ways. These will be weapons that have a speed that will change the nature of war, that you won't be able to defend yourself. They'll change the scale of war, they'll industrialize warfare. With one programmer, you can do what used to take 1,000 soldiers. This will be a step change, like nuclear bombs were a step change in which the speed and efficiency with which we could kill the other side.
A lot of the work in quantum machine learning is, I think, people with people with some background in physics and some background in quantum algorithms, quantum computing, look at some of those algorithms that people use in approaches like deep learning, these Boltzmann machines that people sometimes use in those classical algorithms, and I think that looks like the sort of problem that we believe quantum computers can do better than classical computers.
Any quantum system, its lifetime is characterized by its interactions with its environment. And so in order to be useful, we want a quantum system that can do a lot of calculations, so has very small amount of interaction with its environment.
Users may emerge in 7 years, and when I think of the timelines of policy decisions, modernization efforts, construction of weapon systems like submarines, we're talking 10 to 30 years.
It's been an amazing transition to see research carried out almost exclusively in university laboratories, moving over not just to large corporates, but also to venture capital-backed startups like my own, like Q-Control.
If you can just build one of these quantum machines, then you can solve problems that are otherwise impossible to solve.
I'm interested in encoding information in higher dimensional quantum systems. Like, for example, in my favorite information carrier, which is light. So I am looking at the different shapes of light as a set of letters over which you can encode quantum information.
And if we're going to tell a story that links together the possibilities of quantum computing to their political and economic effects, that doesn't happen in a straight line. In fact, we have to go through at least a couple of different steps. We have to look at the effect of quantum computing on cryptology.
Much of our e-commerce today will potentially be impacted by the advent of greatly increased step change in computational capabilities, whether they're quantum or not. Quantum just happens to be a potential catalyst towards this with Shor's algorithm. So the worst case, in our opinion, would be that global electronic trade just comes to a halt.
Where nothing is capable of being intercepted and decoded, then that potentially has ramifications for peace, because it suddenly raises the confidence of those who would be relying on secure communications to plan assaults against the established order.
We see quantum mechanics as an inspirational form of formalism that can allow us to think about modeling in cognitive science in a different way. The event space allows us to develop models that are more aligned with, for example, how human beings make decisions.
This is venture capital through a strategic mindset, which picks the kinds of research that we follow through to maturity.
Traditional U.S. military advantage, including these major platforms, could be quite vulnerable to asymmetric capabilities like swarms that are actively under development by the Chinese military.
Fields of scientific and technical knowledge, when it comes to designing things from them, they are inherently open and flexible. They can be designed in a number of directions. So here's an example, the principles of aerodynamics. You could end up with the Qantas Dreamliner, or you could end up with the F-16.
The system itself has the sensor decision action chain totally contained within the system. The system makes the decision who to kill and when to kill them.
We know how to make intelligence. We've been doing it for millions of years. And so the question is, like, what is it about artificial intelligence? And it's the dream of control. Right? The dream of control is the reason why we want artificial intelligence. And the problem there is there's a philosophical problem there. Because if we equate consciousness with intelligence, then it's by definition beyond control. So I think it's an impossible dream. My concern is, what are the accidents of impossible dreams?
So come on down and join us at Q Station. My intention is to finally get Alex there, even if he's got to take a boat.
I don't fly.
Do we have time for a couple questions, or? Thanks.
Yeah, a couple of questions. I want to make sure that Peter has his shot on my time. You take my time.
No. Please.
I'm back to trying to understand supercomputation versus, you said versus binary.
Yeah.
Deleuze has used the term 1,000 tiny to talk about one thing or another. Does that help?
It does. I mean, Deleuze was heavily influenced by quantum theories. And basically, I mean, there's a lot of ways to sort of describe this, but it's like every atom could become a computer. And it's a parallel processing computer. And that's what exponentially increases the capacity of quantum, a qubit-based computer. It means instead of having 0 or 1, you can have 0 and 1 and everything in between, which is called probability amplitudes. And the difficulty is reading it, and then usually you have to default or decohere to a classical stage in order to save it. But right now there's 4 different approaches to quantum computing, and that's where there's another race going on. And 3 of those 4 races are going on in Sydney right now, in different centers of excellence. I had the top technology officer of Microsoft on camera saying that they're going to throw the switch to the first quantum computer at Sydney. So, you know, it's a really exciting time, but nobody's really talking about what it means other than simply, we got there first. You know, so. It's terrible, though. I'm putting the dark side on. There's all these great things about quantum, too, right? We should be talking, we will cover that, I'm sure, as well. But I do international security, so that's my job, is looking at the dark side.
Just among other things getting reconfigured, I think the very foundation of IR is centered around a certain kind of actor, the nation state. Because
yes.
One person up there said, you know, what country is going to win this quantum race? Obviously, China is a special case, but it seems to me that any kind of actor.
Yeah. Oh, definitely. I'm thinking, you know, if you're scared now of the monopolization that Google or Amazon or Facebook has, they all have quantum programs. And for good reason. I mean, Amazon could deliver stuff with incredible efficiency with quantum optimization. Google, artificial intelligence, search, you know, algorithms will be completely superior to anything we've ever seen. Also, data mining. So it does have issues about civil liberties. You know, at one level, when I should have prefaced my remarks by saying when I first started this project, and there's an expression in Australia when you make a bet on a long shot, it's taking a flutter on a roughie. That's kind of what Carnegie did, because we were being told it's like 15, 20 years out before there's even like a, you know, 49 qubit computer. And we now have it. And so it means the time frames are shrinking, but there's always a lag between the technological development and our policy recommendations. But in this case, it's pronounced. Okay. One more? Yeah. Sure.
I'm just trying to wrap my head around what quantum communication or technology will lead to change. Is it just speed, or what other ways will it change military?
Well, part of the issue is that in military, one of the ways you win is getting inside the decision-making loop of your opponent, called OODA. What the computer scientist was talking about there is that quantum artificial intelligence basically automates that process, and it means that you'll be able to make your decisions and act on them faster than anybody else can. So it can be used as a preemptive technique as well. But also in terms of gathering intelligence, disseminating disinformation, creating simulations, that's something that quantum computing can do much better than any classical computer can do. I mean, we're all like, you know, the debate about artificial intelligence is still at the classical level. You know, you've got people, very smart people like Stephen Hawking, Elon Musk and others, and people who've signed the petition. But take that to the next level. How many times can we say quantum leap at this gathering? Just once, maybe? Just once? Take that quantum leap. I know I'm misusing it. And that's why I think everybody talks about step change in who are in the scientific community. Jarrett, I'll be really quick.
Real quick tag on to that, which is that I think this is a good moment where you actually need a quantum concept to understand the difference. Because at least for the Chinese satellite model, we're not talking about a difference of speed. We're talking about actual quantum teleportation, which means it's instantaneous. Right? So in an Encoding version, you'd be measuring the bit speed of transfer from Earth to the satellite. They're talking about entangling two different particles, and therefore the slight irritability of the particle on Earth instantaneously being reflected, and then breaking apart, right? The entanglement breaking, meaning there's nothing to intercept or decode. It's not even a question of catching up, because we can no longer use the paradigm.
It's what Einstein derisively called spooky action at a distance. That's the basis of teleportation. So, yeah. All right, thank you very much. Looking forward to the rest of the conference.
Peter? So my role is to make Alex and James look good. And so my remarks will be exceedingly brief.
Do you want to use the podium?
No, I don't. Okay. I will be so brief that you don't look too good. Okay. I want to say one thing about the book. If one looks at contemporary scholarship, at least in the social sciences and the humanities, most of the social sciences, it goes smaller and smaller and smaller. This is a book from the 19th century. I think it is somebody climbing a mountain by yourself, no support. And in my field and in my lifetime, nobody has written a book like that. It takes incredible courage and incredible humility. And it's a book which is very well written, it's very lucid. Okay. So when I read it, it was a phenomenal read, but I was in awe of that Derian, which Alex did. So when I read it, and I called Alex up and said, let's have, I think I called it a soiree in my living room, which we did last year. So I mobilized the intellectual potential of Cornell, physics, psychology, literature, history, international relations, philosophy, right? And we started at 2 and ended at 10. It was 8-hour seminar. Alex was sitting in that chair for 8 hours. One bathroom break. The other ones came, most of them stayed for 6 hours or so, but they couldn't keep up. So it was it was just one of those things I will never forget. So this will be very interesting. As an events manager, I'm building my portfolio. I'm taking notes about how this will work. Okay. And then finally, as James said, he said, I'm sorry that I'm having take the dark view. I think we always take the dark view, right? Alex looks at the positive side and you look at the negative side. Confronted with the unknown, that is the human reaction. So we just encapsulate this. Coming from it, from my perspective, think about history. I find this utterly plausible. It gives me courage to say the past is totally open. The future is totally open. You talk to any historian, the past is always open, always gets remade, reinterpreted, re-envisaged. So I just wrote a book on power. It's all about actualization of potentiality. So I think both of you used the term possibility, or it was Jared, right? You were worried about the accidents and the impossible dreams. I think it's a wonderful formulation. In the end, I come to this with the sensibility that this is not actually social science, although I can see that if you go to what we already see is coming on stream on the technology side, like other great scientific revolution, it is going to transformative effects. But I think in the end, the basic questions are about philosophy and religion and meaning in life. It is about potentialities and actualization. And you read Aristotle, that's what it's about for him. What are we after, oidaimo, well-being, how do we do it? Inside ourselves, during the split, Aristotle, we are relational inside. It is about the actualization of our potentialities. And I go to my theories primarily through introspection. And what Aristotle wrote 2,000 years ago and what Alex and James are talking about is quite similar.